Welcome everybody to the channel Gate Maths Concepts MRCL. It's Ramchandra again. We'll talk about simultaneous equations and matrix elementary operations today. Simultaneous equations. In linear algebra, lecture number 4. What is a simultaneous equation? Let us take a 2 by 2 xy plane. It is x, it is y, and let us say there is a straight line and another straight line is also drawn, and both the straight lines cut at a point P. O is the origin. Then what is the meaning of it? A straight line is represented by y is equal to mx plus c, or we can say first straight line as y is equal to m1x plus c1, and second is equal to y is equal to m2x plus c2. Then these two straight lines are independent of each other, meaning one straight line formation is not dependent on the another straight line formation. Both the straight lines are independent. Can we write the above straight lines as y is equal to m1x plus c1? Can it be written as ax plus by is equal to c? This is straight line number 1, and another is dx plus ey is equal to f. What I am writing, whatever is there, y is equal to m2x plus c2, that I am converting into this form. That's all. These two 1 and 2 are straight line equations in the geometrical form, and they are the simultaneous equations in algebra. And if these two straight lines or equations, they cut each other, they have a common point of intersection, then we can say that they have a solution. These two are simultaneous equations and they have a solution. If the solution is in the real number xy plane, then it is a real solution. If the solution happens to be in the complex plane, then it is a complex solution. That we can say it's an imaginary. The number is imaginary. Then this point P, we can say P11, P12. Let us say that's a point of intersection of these two lines. This is what is the basic meaning of a solution to a simultaneous equation. Now let us rewrite the equations. Ax plus by is equal to c1, or c we can say, and dx plus ey is equal to f. This is equation 2. From these two equations, to solve them, to find the point of intersection of these two lines, we require the value of x and y, whereas a and b are the components of x and y, d and e are the components of x and y in the second equation. Now we have to find the values of x and y to find the point of intersection. Can we write the equation number 1 as in matrix form? Left hand side, can we write like this? Matrix AB multiplied by column XY is equal to matrix C. Similarly, second one, matrix DE multiplied by matrix XY is equal to matrix F. These are all arbitrary numbers. Please don't worry about what are the values of A, B, D, A, C and F. Now, I have to find XY, the matrix XY, so that I can find out the value of X and Y. Then how to find that? This we can say matrix, let us write in the 2 by 2 matrix form, AB, DE, XY is equal to CF. Can we write like this? Let us write like this. Now if you expand, what happens? AX plus BY, next one is DX plus EY, that is equal to CF. That means the original equations are obtained. This form is the most important form. It may look simple, but it's very important concept. From this, the multiplication of two matrices on the left hand side is equal to some coefficient matrix on the right hand side. Now, how to find out, how to extract the value of x from this? How to extract the value of xy from this combination? Can we call this matrix as P? Can we call this matrix as X? Can we call this matrix as Q? Then it is in the form Px is equal to Q. The above equations, simultaneous equations, are converted to this form Px is equal to Q. Now, from this, we can say Ix is equal to P inverse Q. This is a very important formula which is to be understood by everybody. I is nothing but, here I is equal to unit matrix 1 0 0 1. Ix is equal to left hand side 1 0 0 1 xy, that is equal to xy. Xy is written in this form, Ix is equal to P inverse Q. That implies X is equal to P inverse Q. This is the most important formula. where Q is the right hand side constants matrix of constants, P is the inverse of, P inverse is inverse of matrix of coefficients of x and y. Once the coefficients of x and y are known, the matrix and the matrix constants are matrix of constants is known, then we can find the value of x and y. This x and y or the matrix of x, the value of x is not only restricted to 2 by 2 matrix, it can be a 3 by 3 matrix, it can be a n by n matrix or m by m matrix. There is no restriction. Now, if you remember, in my last 3 lectures, I have told whenever the determinant vanishes, there will not be any inverse existing. Determinant under which conditions it vanishes? Please recollect from my previous lectures. Determinant vanishes whenever there are parallel lines in the matrix. This is M, this is N, this is R. If you recollect from my previous lectures, you can understand when OM is equal to ON, area under parallelogram will be 0, determinant is equal to 0. Second condition, if OM is equal to scalar multiple of ON, there also determinant is equal to 0. That means area of parallelogram, when it is 0, determinant is 0. Whenever there is a determinant is 0, what happens? Inverse does not exist. Implies inverse does not exist. If inverse does not exist, what happens? The above equation for the solution of simultaneous equations is not applicable, is not valid. That means the solution obtained or the solution that is anticipated to be obtained from the simultaneous equations under this determinant 0 is not a valid conclusion. That means what is the condition for this equation to be valid? Valid only when inverse exists. When inverse exists? Whenever determinant is not 0. When determinant is not 0, this equation is valid and we can solve the simultaneous equations by this equation. Now, let us see what it means. How to find out the inverse? There are many mathematical formulas for finding the inverse of a matrix to solve the simultaneous equations. And the most and simplest and effective method is to go for the elementary row and column operations. With that we can easily find out the inverse of a matrix. It is a tested, approved method and it's a very good method, a simple method. For that we should have the knowledge of elementary operations of rows and columns of a matrix. Let's go for understanding the elementary operations of rows and column operations. Let us take one simple matrix, 2 by 2 matrix, 2, 3, 5, 6. If elementary row operation is made, from here please find out the determinant. Determinant is very easy, P11 into P22 minus P12 into P21. That is 2 into 6 minus 3 into 5. 12 minus 15 is equal to minus 3. This is from our general formula. Now, let us do elementary, because it's a simple 2 by 2 matrix, you are able to find out the determinant very easily and it is come. I am showing only, I am explaining the concepts, I am only showing the small problems here so that you will understand the concept. Now, let us go for elementary operations, so that you will understand the meaning of the usefulness of the elementary operations. Now, under elementary operations, what happens? I have told you, diagonal matrix, please remember this. For diagonal matrix or triangular matrices, determinant is equal to product of principal diagonal elements. For a 2 by 2 matrix, you have done the operation or you have calculated very simply, but if it is a very big matrix of m by n or n by n, in that case what to do? We have to reduce the matrix to either a diagonal matrix form or a triangular matrix form through elementary operations. From that we can understand whether determinant is existing or not, whether determinant is 0 or not. Then from that we can say that inverse is existing or not. From that we can find out the inverse. Now, for 2, 3, 5, 6, for the simple only we will do. For making a matrix as a diagonal matrix or a triangular matrix or upper triangular or lower triangular matrix, what we have to do, take the diagonal and either below the diagonal or above the diagonal. Ensure that all elements vanish. That means they are equal to 0. For example, in this 2, 3, 5, 6, 2 and 6 are diagonal elements. This is the diagonal. 2 and 6 are the diagonal elements. Principal diagonal. Now either I have to make 3 other element above the diagonal as 0 or below the diagonal as 0. Now, how to do it? This is R1, row 1, from the definitions you know, row 1, row 2, P11, P12, P21, P22. Please remember, I have already told, I have explained what is row and what is column. In this, it is R1, this is R2. Let's go for some elementary operation. What I have to do? I have to make R2 below the diagonal the element to be 0. To make this 5 to be 0, what I have to do? R1 into 2.5 times will be 5, and that should be deducted from 5. Let us see. What happens here? What I have to do operation? What is that elementary operation I have to do? To make whatever row you are operating with does not change. Whatever row on which you are operating, that row values only will change. That means R1 will never change. I am using R1. It will not change. These values will be 2, 3 only. Now, R2 I want to change. I want to make 5 as 0. What I have to do? R1 into 5 by 2. Then it will become 5. I have to deduct that 5 from this. That means R2 minus 5 by 2 R1. What will be the result? R2 is 5 minus 5 by 2 into 2. For second element, it will be R2 is 6 minus 5 by 2 into 3. then what will be its value? R1 will not change because I am operating with it. I am operating upon R2, hence R2 value will change. 5 minus 5 by 2 into 2 will be 5 minus 5. This will be 6 minus 5 by 2 into 3, 15 by 2. 6 minus 15 by 2. You are able to follow? Please follow. This will be R1 will not change. This will become 0 and this will be minus 3 by 2. Now, it is a triangular matrix. The original 2, 3, 5, 6 is transformed or converted into a triangular matrix. Triangular matrix. If something is in the form of a triangular matrix, then what will be its determinant? Determinant is equal to product of diagonal elements. That is equal to 2 into minus 3 by 2. That is equal to minus 3. You see this answer and this answer. Here we have done for the full matrix whatever original value is given 2, 3, 5, 6. Here we have done to the reduced matrix. Now, you take any 3 by 3 matrix also. You take any matrix of that size 3, 4, 5, 6, 7, 8, 9, 10, 2. Let us take. What is the diagonal? Principal diagonal? You please identify the principal diagonal. Then, what I have to do? The elements below the principal diagonal or above the principal diagonal, I have to make them 0. This is row 1. This is row 2. This is row 3. Now, to make step by step, you please go. First, you make R2 as 0, R2 element, which is below diagonal, as 0. Then you go for R3. If we operate for R2, we are only operating on R2 and operating with R1. What I have to do? This R1 I am operating with it doesn't change. I am operating on R2, hence R3 will not change. I am operating on R2. Now, to make this 6 equal to 0 means R2 minus 2R1. That means it will be 0. R2 minus 2R1. 6 minus 2 into 3. That is 0. Here 7 minus 2 into 4. 8. 7 minus 8 is minus 1. And 8 minus 2 into 5. 10 minus 2. This is the resultant. Now, next what I have to do? I have to make R3 as 0 of first column. This I want to target and make it 0. For that what I have to do? R3 minus 3R1. I am operating on R3 with R1. That means my R1 will not change. I am not operating on R2, hence R2 will not change. R3 will change. How it will change? R3 minus 3R1. That means 0. R3 10 minus 3R1 minus 2. R3 that means 2 minus 3R1. 2 minus 15. Here what is the operation I have done? R3 minus 3R1. With these two elementary operations, I have found out the equivalent matrix as 3, 4, 5. 0 minus minus 2, 0 minus 2 minus 13. These two operations I can write simultaneously in a single operation only, like R2 minus 2R1, R3 minus 3R1. This is the result of these operations on this matrix. This is the result. Now, what I have to make? Below the diagonal element, another one also is to be made 0. That is, minus 2 should be made 0. This is the new diagonal. How to make minus 2 as 0? Till now you have operated, for first column you have operated with R1. For second column you operate with R2. Let us go. In a systematic manner we have to do. I am not operating with R1. I am not operating on R1, hence it will not change. I am operating with R2, hence it will not change. I am operating on R3 because I have to make the R3 element as 0. Then what I have to do? R3 minus 2R2. Because these are already zeros, this will not change first column, second column. R3 minus 2R2. R3 minus 2R2, it will become 0. R3 is minus 13. Minus 2R2 is plus 4. That is minus 9. This is because of this. R3 minus 2R2. This is the result. From here we have come to this. Only two steps. First step, operating with R1. Simply R2 and R3 are operated with R1. One step. Next step, operating with R2 on R3. That is second step. This is brought to triangular matrix form. Now what is the value of this determinant? 3 into minus 1 into minus 9. That is equal to 27. How simple it is to find the determinant. Similarly, we can find the inverse also. For a 2 by 2 matrix you have seen, for a 3 by 3 matrix you have seen, and it can be done for even for n by n matrix. Doing elementary operations, we can bring for which it is possible, for the matrix for which it is possible, we will bring it down to diagonal matrix form or a triangular matrix form, and we will get the determinant. For final answer whether it is correct or not, let's again check for these steps may take some 10 seconds or 20 seconds for you. Checking may take for some 10 seconds. A 3 by 3 matrix determinant is found out in below 30 seconds time. Please, let us see first step, whether we have done it correctly or not. It is a recap. 3, 4, 5, 6, 7, 8, 9, 10, 2. First step directly here only we will go. From using this 3, I have to make 6 and 9 0. That means I have to operate 3 and I have to get 6 and 9 as 0. That means R2 minus 2R1 and another is R3 minus 3R1. R2 minus 2R1 means these two are 0. Yes. R2 7. 7 minus 2R1 is 7 minus 8 is minus 1. Then 8 minus 10 is minus 2. This is correct. This line is correct. These two are correct. Now let us see. R3. R3 minus 3R1, 0 is correct. R3 minus 3R1, R3 is 10. 10 minus 12, minus 2. R3 is 2 minus 3R1, 15. 2 minus 15 is minus 13. 2 minus 15 is minus 13. Yes, this is correct. That means one step we have cross-checked in 10 seconds. Next, let us see. What I have to make is here, this particular thing I have to make it 0. To make it 0, because these two are already zeros in the column 1, I can use R2 and R3. I can make so that my first column is not disturbed. What happens now? Minus 1, it is minus 2. Minus 2 plus 2 will become 0. To make plus 2 in R2, that is means I have to multiply with 2 and deduct from this. That means minus 2 R2 will be minus 2 R2 will be minus 2 of minus 1, that will be plus 2 plus minus 2 will be 0. This is minus 13 plus 4, that is minus 9. That means my determinant is 27. Now as a homework you see, calculate delta in traditional manner and cross check answer. Now this is the what you call elementary operations power. With simple elementary operations of rows, by adjusting them, we got some matrices and we brought the original matrix into the form of triangular matrix or a diagonal matrix, and we got the determinant. Once we got the determinant, then you know pretty well, determinant is nothing but determinant of the matrix is nothing but product of eigenvalues. If you want, we can even cross check the answer. Once again, with this 3, 4, 5, 6, 7, 8, 9, 10, 12, I'll do it here only, so that let us clarify. 3, 4, 5, 6, 7, 8 and 9, 10, 2. 9, 10, 2. Determinant will be 3 into 7 2 ja 14 minus 80 minus 4 into 12 minus 72 plus, I am taking first row, 5 into 60 minus 63. Let us see what will be the value. 3 into minus 56, sorry, minus 66 minus 4 into 60 minus 60 plus 5 into minus 3. Please see whether I am right. This is minus 198 plus 240 minus 15, that is equal to 42 minus 15, that is equal to 27. That means we have cross checked it. And there can be complicated questions also than this, and elementary operations are very simple to do, and it's only an easy way of doing elementary operations, and we can get the answer. And the main advantage of doing elementary operations, what is the main advantage? The main advantage of doing elementary operations and getting determinant is to get the inverse very easily. Elementary operations on matrix will give inverse very easily. And in a computer science era like this, data management and artificial intelligence and machine learning, we can't go on putting what you call formulae. It is better to operate using the operators. Matrix operation, elementary operations is a very easy process where data management processing will be very easy when you do the elementary operations, rather than what you call feeding the formula like inverse is equal to 1 by determinant into what you call transpose and all those things, adjunct A, all these things formula. Instead of a formula, We have done simple elementary operations and we got the determinant and we ensured that determinant is existing. When determinant is existing, there is a solution is existing and there is an inverse is existing. That inverse will be calculating through elementary operations very easily. Now, using elementary operations of rows and columns, let us check or find a method to find out the inverse of a matrix. The meaning of the inverse of a matrix I have already told in the previous lectures, that when a matrix in xy plane, let us take 2 by 2 matrix, what it represents? It represents a parallelogram. When the parallelogram is shrunk to unit size, then that particular operation gives us the inverse of the matrix. This is m and n and they are brought to its unit size, then that process gives us the inverse of a matrix. This is the matrix A, let us say. Now, how to find the inverse of a matrix? There are many mathematical formulae. Without going into the complicated mathematical formulae, with elementary row and column operations, we can find the inverse of a matrix. Now, ultimately, what is inverse? Inverse is nothing but A inverse A is equal to I. I is an unit elementary matrix where I is equal to either 1 0 0 1 or whatever may be n by n matrix with all principal diagonal elements as unity and all other elements as 0. That is the value of I. Now, to find the inverse of a matrix using elementary row and column operations, what we have to do is that the given matrix A to be separated by a line, please listen to me, then the I matrix of n by n is to be written and the whole matrix is, both the matrices are to be embedded in a bigger matrix form. This will be then elementary operations to be performed on them. To be performed on this bigger combined matrix. I will explain. And to ensure that in the process A becomes I and I becomes A. I becomes inverse of A. A becomes I and I becomes A inverse. That is what is the concept. Let's go through the process. Let me take A is equal to 2 3 5 6 2 by 2 matrix as taken in the previous example, and for 2 by 2 matrix I is equal to 1 0 0 1, which implies the bigger matrix will be, combined matrix will be 2 3 5 6 1 0 0 1. Let us do the elementary matrix operations, rows and columns operations on this combined matrix. Whatever elementary operations we will be doing, we have to ensure that this 2 becomes 1, that and this 3 becomes 0, that means the form of I should be on the left hand side, and right hand, automatically the right hand side will give the inverse. This 5 becomes 0 and 6 becomes 1. Let us see how it is to be done. Now, to make 2 1, the first row first element make it as 1. To make first row first element make it as 1, we have to divide that particular row by that number, by that element. Then it gives 1, 3 by 2, 5 and 6. What we are operating? Here we are operating R1 by 2. So the 2 becomes 1. R1 by 2, here right hand side what happens? This becomes 1 by 2, this is 0, this is 0, this is 1. This is the first step. In the second step, what we have to do? Previously what we have done in the example, that we have made the second row first element as 0. Here to make second row first element is 5, to make it as 0, what we have to do? R2 minus 5R1. Next operation is R2 minus 5R1. What is the result it's going to be? R1 will not change because we are operating with R1. R2 will change. R2 minus 5R1. This becomes 0. R2 minus 5R1 will be 6 minus 15 by 2. Here R2 minus 5R1. R2 is 0. 0 minus 5R1. Then 1 minus 0. Because whatever elementary operation we do, that operation will be done on both the matrices. Then next, this becomes, simply we can write it as 1, 3 by 2, 0, minus 3 by 2, and half, 0, minus 5 by 2, and 1. Now, next what we have to do? Let us add R2 to R1. So that in the second column, the first element of the second column should become 0. Next, R1 plus R2 implies, what it implies? R1 is 0, 0 plus, by multiplying and adding 0, it will not make any difference. R1, first element is 1 and this is 0, it will not change. And here 3 by 2 minus 3 by 2 will be 0, here it will be minus 3 by 2, and in this it will be half, minus 4 by 2 will be minus 2, 1, because 1 plus 0 will be, 0 plus 1 will be 1, and because we are operating with R2, R2 will not change. Now, this with practice you can do it in seconds, there is no problem. It is only because I am doing it for your concepts, to make your concepts clear. Next, 1, 0, 0 minus 3 by 2, minus 2, minus 5 by 2, 1, 1. Now, I have to make minus 3 by 2 equal to unity. This I should make it as 1. Then what I have to do? I should multiply this minus 3 by 2 by minus 2 by 3. Means, what I have to do? R1 I will not change. R2 I will change, multiply with minus 2 by 3 R2. It implies what happens now? 1, 0, it will not change, 0, 1, and when I multiply R2 with minus 2 by 3, it will not change. When I multiply with 2 by minus 2 by 3 R2, minus 5 by 2 into minus 2 by 3, it will be 5 by 3. And 1 into minus 2 by 3 is minus 2 by 3. That means it gets a form 1, 0, 0, 1, minus 2, 1, 5 by 3, minus 2 by 3. This is A inverse. Because left hand side we made it as I, right hand side is the inverse of that original matrix. What is the original matrix? A is equal to 2, 3, 5, 6. A inverse is equal to minus 2, 1, 5 by 3, minus 2 by 3. It's very simple. Within 3 steps we got this answer, and within few seconds you will be able to answer this. Now let us cross check whether A inverse is how much. It will be 2, 3, 5, 6, minus 2, 1, 5 by 3, minus 2 by 3. This is equal to minus 4 plus 5, minus 10, plus 10, plus 2, minus 2, plus 5, minus 4. That is equal to 1, 0, 0, 1. A inverse is equal to I. We got the inverse of the matrix with elementary operations very easily. What we have done is for 2 by 2 matrix. We can even extend this to the elementary row operations can be easily performed on any square matrix to find the inverse, provided determinant is not equal to 0 and inverse exists. And inverse exists. This is the condition. Now, for example, while doing the elementary operations, one of the rows becomes totally 0. Then what happens? The determinant becomes 0. Let us think. A1, A2, A3, B1, B2, B3, C1, C2, C3. I have done the elementary operations. The result found to be sum P1, P2, P3, Q1, Q2, Q3. Then what it means? For example, let us say this also is 0. This also is 0. It is a triangular matrix with only 2 rows having non-zero elements, and the third row in a 3 by 3 square matrix, third row after elementary operations is totally 0. Then what it means. What it means. Give your mind little work of thinking and try to understand if the result after elementary operations looks like this, what is the meaning of it, and try to find out the inverse of the 3 by 3 matrix. Homework is find inverse of 3 by 3 matrix used in this lecture by using the row elementary operations. This is your homework, and this previous one, after elementary operations the situation comes like this. Then if one of the rows becomes totally 0, what happens? By the look it looks determinant is 0. If the determinant is 0, does inverse exist? If it doesn't exist, then what is the meaning of it? What is the physical meaning? Please have a thought. We'll further discuss on these determinants and simultaneous equations in detail in the next class. Best of luck to everybody.